All right, we are going to do the second page of the notes. We're going to graph two more quadratic functions that are given in standard form. So notice the standard form. A is -2, B is 4, C is 0. Direction of opening, it's going to be down because A is negative. So if you need to give a reason for why it's opening downward or how we know it's opening downward, it's because A is negative. The vertex is a point, so let's find the x-coordinate by using our little formula, h equals -b over 2a. So we'll plug in the b value and do the opposite. Oops, plugged in the wrong value. We need to plug in the 4 for the b and the -2 for the a, right? So we get -4 over -2, 4. Whoops, man, must be time to be done. -4 divided by -4, which is +1. Got to find the y value that goes with that x value. In other words, the k, the y coordinate of the vertex. We're just going to plug that back into our function. Plug what back in? The x value. X was 1. This is an x value right there. To find the y value that goes with it, use your rule for the relationship between x and y. So that's going to be, oops, I forgot my square. That might be important. -2 times 1 squared plus 4 times 1. So that's going to be -2 times 1, which is -2, and then plus 4. Okay, so -2 plus 4 is +2. So our vertex is at the point 1, 2. There's our vertex. All right, I'm going to put that into my graph. We know it opens down. We've got a vertex. We're going to put our vertex on the graph. Go out to x equals 1 up to y equals 2. There's our vertex. I'm going to draw in the symmetry line as a dashed line. Remember, it's a vertical line through the vertex. There it is. Vertical line through the vertex is our axis of symmetry. Splits the parabola into two identical halves. Is that vertex a maximum point or a minimum point? Parabola is opening downwards, so that vertex is going to be a maximum, a high point. Visualize it. It'll help. Parabola opens down. Vertex is a maximum. What is the maximum or minimum value? That maximum value, we've already got it. It's going to be y equals 2. It's going to be the biggest y value. So the maximum, it's a maximum, and it's 2. Graph is going to go down from there. Axis of symmetry, the vertical line x equal 1. Y-intercept, when x is 0, y is also 0. It's that c value. Remember, the c value is the y value, or the value of the y-intercept. 0, 0. Domain is going to be all real numbers. The range, let me hold on to that one for a minute. Before I do that, we're going to look at the graph a little bit. So I'm going to make a quick little table, find some other points on the graph. We've got this one. Y-intercept is at the origin. Our vertex is 1, 2. We got 0, 0. We should have 2, 0. Let's see if we do. If I plug in 2 for x, do we get 0 for y? 2 squared is 4 times -2 is -8. -8 plus 8 is 0. Good. I feel like we're pretty confident that we have the vertex in the right place because we've got that symmetry going on. That's a way to check that you have the vertex in the right place. Okay. We're going to do a couple more points. I'm going to go with x equals 3. So if x is 3, I can just do some replacing here. -2 times 9, because 3 squared is 9. That's going to be -18. Plus 12 is -6. Okay, so we had 3, -6. Oh, we're not going to do any more because the next one's going to be off the graph. And then if we use the symmetry, we count to our symmetry line. There's 1 unit, 2 units, 1 unit, 2 units right over here. -1, -6 would also be on the graph. And you could put that in the table or not. I don't really care, but you could check and make sure that you do really get that value. Draw a nice smooth curve through these points. Remember, it's not a line. It's a smooth curve, so we're going to curve it. Instead of making straight lines, we're going to make it curve. And we have that. I'm not super happy with that, so I'm going to redraw just a little bit right there. Still not super happy with it. Okay, so there is our quadratic function. All right, there's our quadratic function. Now the range. Notice the largest y value that we have is a 2, and we have all the other y values. If we follow it, it goes down forever. So the range is going to be all y values less than or equal to 2. That would be one way of writing it. Another way of writing it would be, oh, now we have to be careful. Remember, when you're doing interval notation, you have to go from the smallest to the largest. So we go from the bottom to the top. So negative infinity, because it goes down forever. And then we end with a high value of 2, and we use a bracket around the 2. That's our interval notation for the range. And we should be able to write it in either way. Be able to use either one of those notations. All right? Okay, third and final example. It's already in standard form. Notice it is standard form. X squared, x, and the -5. Okay, powers go down. 2, 1, none. A is 3, B is -6, C is -5. Direction of opening is going to be up because A is +3. Vertex, I'm going to use the fact that the x-coordinate of the vertex is -b over 2a. I'll write that formula down again. H is -b over 2a. So we'll do the opposite of -6, and we'll divide by 2 times 3. That's going to get us 6 over 3, which is a 1 again. The k value, the y-coordinate of the vertex, we get that by plugging our x value back into the equation, because that equation tells us how to find a y value when we're given an x value. So we'll plug it in. 1 squared is just 1. 3 times 1 is 3. Got 3 take away 6 take away 5. That's going to be -3 take away 5, which is -8. So our vertex, 1, -8. And it looks like we're going off the grid again. Right? Because we didn't go down low enough here. So there's -6, -7, -8. We're going to go off the grid a little bit. We got 1, -8. I'm going to draw my axis of symmetry right through the vertex. Vertical line through the vertex is your axis of symmetry. Let's write it. Oh, let's fill in some of this information. So the vertex is going to be a maximum or a minimum point. It's opening upward. So my vertex is going to be a low point, which is a minimum. Okay. And what is that minimum value? It's going to be -8. It's as low as it's going to go is a y value of -8. Axis of symmetry, x equals 1. H is 1. Vertical line through the vertex, notice what it is. It's that vertical line where x is 1. See it? It's 1. X equals 1. Y-intercept, and we just look at the function. The y-intercept is the c value, so 0, -5. So we've got this point right here. We can use the symmetry line to get another point, and if you're wanting to check your answer, you can plug in x equals 2 and find out that when x is 2, your y value is, let's see what it is, 3. 2 squared is a 4, so that's going to be a 12. Minus 6 times 2, which is another 12. Oh, there's a 0. 0 take away 5 is -5. It worked. Yep. Okay. Calculation done. We've got the vertex in the right place because we've got the symmetry going on. Domain is going to be all real numbers. And the range, what y values are going to have? We're going to have -8 and everything bigger, because from -8 for the y, we're going to go up. So -8 is our smallest. We get all y values greater than or equal to -8. Or we could write an interval notation as smallest is -8. Use the bracket. Where are we going? Up forever. We're going to infinity. All right, we're going to put a couple more points on that graph, though. I want to find what happens when x is 4. So we've got our, 3. We've got 2 comma, oops, what did I just do? When x is 1, y is -8. When x is 2, y is -5. I'm going to find out what happens when x is 3. So I'm going to plug in a 3. 3 times 3 squared. 3 squared is 9. That's going to be a 27, right? We're going back to our function, right? 3x squared minus 6x minus 5. We're replacing the x with a 3. So we have 3 times 3 squared, which is 3 times 9, 6 times 3, and then minus 5. I'm going to get good at plugging these numbers in. Okay, let me do it down here. 3 times 3 squared minus 6 times 3 minus 5. That's going to be 27, take away 18, which is -9. Oops, positive 9. And then 9 take away 5 is 4. So we have 3 comma 4. We're way up here. We'll have a partner on the other side. We go 2 units on the other side. We have that point. Do you notice what happened with this parabola? This one is narrower. That's because A is 3. It's making it steeper. It's making it narrower. Smooth curve. And that is our third and final graph.